Hello and welcome back to another LeetCode problem. Today we're going to be doing the problem of the day for June 23rd, longest arithmetic subsequence. So this problem is pretty similar to the other problem called longest arithmetic, longest increasing subsequence. In which case the only difference for that is when you have some numbers like this, you actually want the longest just increasing subsequence and there is no priority for that. And so the way that one works, that I'm going to explain after just going over these examples, is going to be very similar to how we do this. But so here, the difference is we have to have a subsequence that increases or decreases by the same amount the whole way through to be counted as a subsequence. So for example, for here, every single number is added by 3 to get the next one. And so this whole thing is a subsequence, and you would get a 4. Now, for the next number, let's take a look. Also, to get some hints on how to do this, so they're saying you can delete some elements. It's a subsequence, it's not continuous, meaning it's probably going to be a DP problem just like the other one was. So that's a hint that you get there. And so here, the longest increasing subsequence they're saying is actually this 4, 7, 10, where we are increasing by 10 and we can delete these two elements. And then the last example. Okay, so the last example here, they're saying the longest subsequence is this right here. So we delete these elements because all of these are decreasing by 5 at every stage. Okay, so how would we do this? Let's actually take this last example and figure out how we do this for the longest increasing subsequence, and then we can figure out how to change that to the longest arithmetic subsequence. So 3, 10, 5, 8. Okay, so if this was just the longest increasing subsequence without a, or let's just say longest increasing or decreasing subsequence even, but let's just keep it increasing for now. So let's say we're trying to get the longest increasing subsequence. It's actually pretty straightforward. The way that would work is for every single number, we can just look at every number before it and ask, okay, is that number smaller than this number? And if it is, we can just add this number to the end. And so the longest increasing subsequence for that would be that plus 1. Let me show you what that would look like, actually. So let me draw like the DP for those. So for 20, the longest increasing subsequence in our arithmetic would just be 1 because it's the first number. Then we would go to 1. So for 1, we'd check every number before 1 and we'd say, is it smaller than 1? And if it is, then we can always add the 1 to the end. There's nothing smaller than 1, so 1. For 15, is there any number smaller than 15? And we have to check all of them, and we have to figure out what's the longest subsequence with that number, and we can add a 1. So for 15, we're going to look at the 1 and the 20, and then we can say, okay, 15 is greater than 1, so we can have a subsequence like this, so that would be size 2. So that would be our answer there. Now for 3, we'd have to check every number smaller than 3. The only number smaller than 3 is 1, and the biggest subsequence with 1 is 1, so that would be 2. For 10, we'd check 3. So for 3, we have 2, so that could already be a 3. We can also check a 1, and for 1, we have 1, so that would be 2. But we'd rather use the 3, right? Because then we could use the 3 and the 1. So that would be size 3. For the 5, we can't do the 10. We could do the 3, which has a 2. We could do the 1, which has a 1. We'd rather take the 3, right? Because then we have the 5, 3, 1. And so that would be a 3. And then for the 8, we could take the 5, which has a 3 already. So that would be a 4, right? It's a 5, 3, 1, this. Or we could take the 3, or we could take the 1, but the longest increasing subsequence that's smaller than 8 is 5 that we could actually use. So we're going to take the 1 with 5 and then add the 8 to the end, and so that's going to be a 4. So that's how we would do that. Now, the problem here is we can't, like, our numbers aren't necessarily only one greater. They can be any number greater, right? They can be any number greater, and they can be any number smaller. So we are going to do something similar, and this is actually one of the few problems that bottom up is easier to explain than top down. It's very rare that that happens for DP, but this is actually one of the few ones that happens for. And I'm going to show you the algorithm. It's going to be kind of similar to this, except we're not actually going to use an array this time. We're just going to use a hash map, because a hash map is going to be easier because we don't necessarily know what values are to the left of like the value we have, and we don't necessarily know the differences beforehand. So it would be trickier to have an array because it would have a lot of blank spots, and I'll show you how that would work. Okay, so let's say we have this again, and we're going to follow kind of the same logic here. So we have a 20, a 1, 15, 3, 10, a 5, and an 8. And then we need to establish a base case for every element. And so the base case for every element, they tell us that the array is at least size 2, and an increasing arithmetic subsequence of just 2 numbers can always be true, right? No matter what. Like, any 2 numbers will work as a 2-length arithmetic subsequence because the difference will be the same as nothing else because there's only one thing, right? So it can never break. So like any 2 numbers will have a length to arithmetic subsequence. So knowing that, we are actually going to use that and construct the bigger subsequences, and I will show you how to do that. So we're going to have a visited hash map instead of a DP, and we're actually going to have it's going to have 2 variables that we're going to have. We're actually going to have the like index we're at, so it'll be a tuple for the key, the index, and then we're going to have the current index that we're at, like the value at the current index. So we'll just say vi minus v of whatever we're comparing it to. We'll call that like v previous or something. And this is kind of similarly as we did it on the left, right, where we compared every value to values that were smaller, except now we can compare every value to every other value. So let's show you how that's going to look like, and we'll explain this a little bit better. Okay. So we're not going to do the 20, so we're actually going to skip the first element because the first element will be only a subsequence 1, and so we're never going to want to really use a subsequence 1. Like, we don't need to store that. So we're actually going to start here. So at this first element 1, we're going to check every single number to the left, and we're going to say, okay, what's the difference between these 2 numbers, and what's the difference between these 2 numbers, and like what's the subsequence with the last number? Okay, and if there is no subsequence with the last one, then we can just say our subsequence is the current number and the number we're comparing to, because like I said, a subsequence of 2 is always going to be valid. So we're going to be at this 1, and we're going to be at this 1. So let's just say I'm actually going to use a color here. So we're going to use this is going to be the right. This is going to be the left. Okay. And so we are going to take the difference. And so the difference will be 1 minus 20. So it's going to be negative 19. Then we're actually going to look in the hash map for this left. And we're going to ask ourselves, okay, is there something in the hash map at this left index, at v left index? And then the difference, so let's just call that the negative 19. Is there something? Well, no, because for 20 we didn't store anything. And if there isn't, we're just going to say we're going to use the value 2. Okay? So this right here will be value 2. And so we're going to store that in our dictionary as well. So we're going to have v of this is going to be, let's say, index. We can index these as well. So this is index 0, index 1. So v at index 1, and then difference negative 19, right, is going to equal 2. Okay, now we move on. So we can move on over here. We might not go through the entire thing, but I'll kind of show you how it's going to go. Okay, so let's just maybe change the colors. So now this is going to be our right, and then we have to check every single left. So we're going to check this left, and we're going to say, okay, what's the difference here? The difference here is 15 minus 1, right? Right minus left. So the difference here is 14. And so we're going to check for here, we're going to check as well, okay, is there a v at index, this is what, index 1, and difference 14? Well, clearly there's not. We never saved anything there. We do have a value at, so this should actually not be at I, this should be at index 1. Okay, so we do have a value at index 1, but we don't have a value at index 1 with a difference 14. So if there's nothing there, then once again, we're going to default this to be v of, and we can actually write that in here. So we can say v of index 2 with a difference of 14 is going to be length 2. Now we're going to check this. And what's the difference here? 15 and the 20, so it's 15 minus 20. It's going to be negative 5. And now we're going to check that index. And there's nothing in the 20, remember, because we never stored anything. So there, we're never going to have anything. So we're going to assign the default value as well. So we're going to say 2, and then the difference here is negative 5 is 2. Okay, so now we checked every single left for that particular, right? So we're going to move on. So we're going to move on, and our new right value is going to be, let's use another color, like green. This is going to be our new right value. And so we're going to compare it to every variable that we can as well. So we're going to compare here. The difference here is negative 12. And obviously there is no negative 12, so clearly we can already see that we're going to have a new value here. So this is v, and this is at index 3. Yeah. With a difference of negative 12 is going to be 2 as well, because we didn't have a negative 12. Now we need to compare it to the next value. So we're going to compare it to this value over here. So the difference here is 2. Well, we never had a 2, so that's not going to work either. So the difference here, 2, is going to be 2 again. Okay, now we're going to compare it to this last one, this 20. It's going to be negative 17. We never used negative 17, so we're going to have to store that as well. So v3 negative 17 equals 2. Okay, so now we did that. Now we're moving on. Now we have a new right value. Let's use a different color like this. And now we are at this value here. Okay, we're going to compare it to the 3. The difference here is 7. We don't have a 7, so that can't possibly be repeated. So we're at index 4, so 4, 7, okay, equals 2. All right, now we're going to compare to this 15. The difference here is negative 5. And we actually do have a negative 5, and we do have it negative 5 at index 2, right? It's this thing right here. So if we do have it, that means that we have a like a sequence here that actually does have, you know, difference negative 5, and it's length 2. So if we have something that's length 2 that's with negative 5, we can just add the 10 to the end. And so we take whatever value this is and we just add 1. And so we're going to write it over here on the right. So it's going to be v, and we are index 4. Negative 5 is going to be 3. And so you can pretty much tell that, like, well, we'll do the last of this one, and then we'll do the 5, and then we'll stop. Okay, so we're gonna go over here. The difference here is 9, right? 10 minus 1. Do we have a 9? We never have a 9, so, or we don't have a 9 currently, so that's fine. Okay, and so yeah, so this is supposed to say 3. It's kind of bad handwriting, but it's okay. So v, okay, so we have 4 with a difference of 9. It's going to be 2 as a default. Now we are going to compare it to the 20. It's negative 10. We don't have a negative 10 either. So v4 negative 10 is going to be 2. Okay, now that we went through all that, we're going to just go to this 5 and we'll stop. And so for the 5, let's use one last color here. So we're going to use it right here. Okay. So we're going to compare it to the 10. And this is a negative 5 difference again. And do we have a negative 5 difference at index 4? This is index 4. Yes, we do. And so that's right here. So we are going to reuse that. So we're going to say, okay, if the array that ends with this is length 3 and its difference negative 5, well, we can just add the 5 to the end of that. So we're going to take whatever that is and add 1. So that's going to be at index 5, difference negative 5 is going to be 4. Now we compare it to the 3. We have a 2. Do we have a 2 anywhere? Yes, we do. At index 3, do we have a 2 at index 3? Or sorry, we don't have a 2 difference. So the 2 has to be on the right. Actually, we do have one right here. So at index 3, we do have a 2, right? So that's going to be this 135 sequence. Yeah. And so that we can add that there. So that's going to be 5, negative 2. And so that's this one right here. So now we're going to take the old value, add 1. So that's going to be 3, a 135 sequence. Now we are going to compare it to 15. So that's a negative 10. Do we have a negative 10 at index 2? Let's see. I don't believe we do. No, we do not. So we are going to just make that as a default. So v5 negative 10 equals 2. And that makes sense, right? Because we need a 25 to make that sequence. We have a 15 and a 5. Okay, now we're going to go to the 1. That's a difference 4 at index 1. Do we have that? No, we do not. So v5, 4. And then we have one more. So that's 2. Then we just need to compare it to the 20 of a difference negative 15 and we don't have that as well. So hopefully this fits, but so this is a difference of -15, and that's going to be 2 as well. And so pretty much, we're not going to do this 8, but pretty much because we know that our longest thing is going to be 20, 15, 10, 5. But pretty much all we do is once we construct this whole thing, now we just figure out like what's the maximum value in this whole thing, and then we can return the output. So the maximum value is going to be this one right here, v of 5, -5. So v at index 5, 1, 2, 3, 4, 5, with the difference of -5. And that's the one we want, right? Because it's going to be 20, 15, 10, -5. The difference there between every number is -5. So hopefully that makes sense how to do it. And I'm just going to write it out as like pseudocode here, smaller font. So one, we are going to loop through every number in the array except for first one. Then we have inner loop from every number up to before the number we are at, right? So if like this first one is I, the second one will be j, so j will loop up to, you know, I minus 1 or whatever it is. Okay, and then we have a couple cases, right? So if we have a value when we subtract the two in our dictionary, we can use that and add 1. Otherwise, we default to size 2 sequence, right? So if we don't, like when we subtract our two numbers, like let's say we have the 10 and the 5 and the 15, if we subtract them and we get a -5, if we don't actually have a -5 difference at whatever index this is, then we're just going to default to size 2 because we know that a size 2 sequence is always valid. And so finally at the very end, it's pretty straightforward. We're just going to return the max value in our dictionary. So we're gonna set up this dictionary and we're gonna return the max value. And yeah, the reason we don't really want to use, like normally in DP we want to use arrays. The thing is that we're subtracting the left number and a bunch of right numbers, and so those differences can be like very different. So they're not going to necessarily be in order. So that's why it's better to just use keys and values in a dictionary for our DP as opposed to an array, because they're not going to be like in order. So hopefully that makes sense, and let's code it up now. So we're going to have a visited. And yeah, it is possible to code this up with top down, but it's definitely super unintuitive and it's hard to get it down to like the time and space complexity that you need. But you are given somewhat of a hint to know that like this can be quite complex, because the nums length and the nums I are pretty small values. So, you know, they're quite lenient on letting you pass. If you have like an n² solution, that should pass. n² log n. I think maybe n³ won't pass, because if you have n³ and you have to, let's say, iterate through this 3 times, like n³ times, that would be 10 to the 9th. So that wouldn't pass. Okay. So now we are going to, so we're going to have a right value and a left value, right? Where our right value is going to be, like in our example, our right value is these green values, and then the left value is the one we're comparing them to. So what we're going to say for right in range. And remember, we're not going to do the first value because there's no point there. So we're going to do 1 length nums, and then for left in range. And remember, the left has to be less than right. So we can just do right here. Now, what are our cases? Well, it's pretty straightforward. So we need to get a difference. So we'll just call that diff equals, this is going to be nums right, because the right and the left are just indices. So we're going to get the difference. And then now what are our cases? So if left and diff, right, the index of whatever we're comparing our number to, and the difference is invisited, we can use that. Then visited right diff equals visited left diff plus 1. It means like we have a sequence and we have the perfect number to subtract from. Like in this example, if we're at the 9, we're comparing it to 6. The 6 is already length 2, so we know that, and it's the difference is 3, so we know that we can just add the 9 to the end of whatever sequence the 6 ends with. Just like our longest increasing subsequence. Now, like I said, the only difficulty is we have to keep track of this difference to make sure the difference is the same. Where longest increasing subsequence, we can just take any number smaller than the current number, and we can put the number to the end of it, but now we can't. Okay, so the other case is, remember, we are going to have a default value of just 2. Okay, and that should be it, I think. Now we just return the max value, and so that's going to be visited in Python. You can just look through the values. You can just look through the values list and return the max value, because this is going to be the key and the values will be on the right. And so I think that's it. Yeah. Okay, perfect. But yeah, this is one of the few, hopefully it compiles. Yeah, okay, nice. So this is one of the few rare ones that bottom up is more intuitive, because we're going backwards is more intuitive than going forwards, for sure. Because I originally tried to do this, doing a memoization, and I think I was able to do it, but it was definitely super confusing. So, okay, and so now let's think of the time and space complexity. So for the time and space here, what are we doing? So we have a nested for loop that goes through every single number on the right and every single number on the right and left, right? So there's a nested for loop that can go at worst n squared, and then these n's are big O of 1, so that doesn't matter. This is n squared, and then space is going to be n squared as well, because our visited can hold any difference. So actually this shouldn't really be n squared. This should be more like, so if nums I can be 0 to 500, let's just say this is going to be like the, maybe like max difference or something. Because you're subtracting numbers, so whatever the max difference is that you can have is going to be one dimension, and the other dimension is going to be the num's length. And so it would be these two different parameters multiplied by each other, because the difference is the two numbers subtracted by each other, but then you actually do have to iterate through every single number. So that's going to be this right here. Okay, and I believe that's it for this problem. And if you liked it, please like the video and subscribe to the channel. And then some people posted that they have some other problems that they're not sure how to get in my in some of my other videos. And so if you do have problems that you would want me to make a video of, you can just write that in the comments of any video. I do watch the comments a lot, and then I'll happily make a video for whatever you guys want. Okay, so that's going to be all for me today, and we'll see you later. Bye.